Alright, so let's take a look at this second problem, or at least I think it's a second problem. When I cut and pasted it, I didn't catch the number. Alright, so we are to identify intervals over which the function is increasing and decreasing. This time I see the arrows are indicated on the graph. If I start here on the left hand side, as x increases, what's going on with the y coordinates? Well, I see that as x increases, the y coordinates are also increasing. When I have the an arrow that's indicating either positive or negative infinity, to the left is negative infinity. I'm wanting the x coordinates, not the y coordinates. And then as x increases up to -2, over this interval of x's, I know that the y values, the output of this function, is going to be increasing. Now I can see that there's a change here, in that from -2 all the way here, even though it almost flattens out, it never becomes constant. So on this portion, we're going to argue that it's decreasing, and then again when it hits here, it's going to become increasing again. So when I'm on this interval, or when I'm over on this yellow shaded interval, as x increases, the y values are also increasing as any 2 points that you pick in the interval. The x coordinate here was 2, and since I'm going off to this arrow, and that's going to the right as well as going up, but I'm interested in the x coordinate going to the right, that's positive infinity. So if you're in this interval, or if you're in this interval, then the function is increasing. The mathematical symbol for or looks like a capital U, a large U, and it's referred to as the union of these two intervals, and you can interpret it as the word or, that if you're on this interval, or if you're in this interval of x's, the output of this function will be increasing. Now let's take a closer look at that green portion that I've highlighted there. Let's get this a little bit out of my way. So pick any 2 points in this interval. As x increases, to stay on the graph, you have to go down. So the output of the function is decreasing. So at the start of it was here, and then it changed here. So the x coordinate here is a -2. And the x coordinate here is a +2. So if x is in this interval, the output of our function is decreasing. So now to determine whether this function is even, odd, or neither, we want to look at the graph and see if we can identify symmetry. I'm going to erase this just to get it out of my way. Alright, so I can easily, or at least I think it's easy to see, that this is not an even function, and that's because I clearly do not have symmetry across the y-axis. On the left part, say that this would have to be going up and then down. It would have to look, and this portion would not look like this. It would look like that. Or if I picked the other side and reflected it the other way, you would have the y-axis being a mirror, and the left-hand side and the right-hand side would be mirror images of each other. We clearly do not have that, so this is not an even function. So now, can we determine whether or not it's an odd function or not? With an odd function, you have symmetry with respect to the origin. So one way that I've always done that is also look at that as a rotational symmetry. If I put my pencil there at the origin and I reflect the graph 180 degrees, do I get the same picture? Well, it looks to be the general shape, but look at the height of this. You're 6 units above the x-axis. Here I'm only 2 units above. So I don't have the same graph. I have the same shape, but it has to be identical this is not an odd function. Now the algebraic definition, we could apply that here as well. That if you look at two x values that are equal and opposite to each other, are the y coordinates opposite of each other? So if I look, say, at this point that has a 2 and the output here is a negative 2, if this is an odd function, then I would expect to also see that the opposite of 2 is negative 2 and the opposite of negative 2 is positive 2. I would expect to see negative 2 comma 2 as a point on the graph, and it's not. Now if it were, I have to be careful. It has to be true for all points, not just a point that I select. But here I clearly find a counterexample that this is not an odd function. So since it's not odd and it's not even, we say that it's neither. So I hope that helps.